Hello all, I'm back once again. Let me share with you how you can solve the second numerical. The second numerical was to scan convert a line from the endpoint 150 to the endpoint 110.65. So let us see the solution. Again, as said earlier, here you will be calculating the slope first. So slope denoted by m is to be calculated as y2 minus y1 divided by x2 minus x1. It evaluates to 65 minus 50 divided by 110 minus 100. So it comes out to be 15 divided by 10. It is greater than 1. So in this case, m is greater than 1. So how did you scan convert a line when the slope is greater than 1? To scan convert a line when the slope is greater than 1, we swap the roles of x and y coordinates in all the expressions. So what does this mean? Let us see what does this mean. Now you will be sampling y instead of the x. Remember, for m greater than 1 you sample y, and for m less than 1 you sample x. So sampling of y means y is equal to y plus 1 always, and we decide the value of x as x is equal to x or x is to be incrementing. Again, this will depend upon the decision parameter p. So if the decision parameter p is less than equal to 0, x remains the same, and if the decision parameter is greater than 0, then x is to be incremented. Now what is the value of p? How p is calculated? Initial value of p is to be taken as 2 dx minus dy. If you see the first numerical, there we had wrote that p is equal to 2 times dy minus dx. But now, because m is greater than 1, so we have swapped the roles of x and y. So we are writing here as 2 times dx minus dy. So p naught, initial value of p here in our case evaluates to as 2 times 10 minus dy. So it is 15. So here it comes to be 20 minus 15. It is equal to 5 greater than 0. So initial value of p is greater than 0. Initial value of p is greater than 0. Again, let us make the same table. X, y and p. The first point to be plotted is, look at here, it is the given point 150. So the first point will be plotted like this, 150. And what will be the value of p in the first row? It is calculated here, p naught, initial value of p, it is 5. So you will write here 5. So because 5 is greater than 0, so in the next step x is incremented. See here, so p greater than 0, x is to be incremented. So we increment the value of x, and y is always to be incremented 51. Here also for y, because now we have to sample the y. Sample the y always. This is the rule. So that means we need to move the y coordinate from 50 to 65. So you can fill up this column like this: 52, 53, 54, 55, 56, 57, 58, 59, 60, up to so on till we reach the y coordinate 65. Again, for every step you need to update p. Now how you will update p here? See, when p is less than equal to 0, like here p is less than equal to 0, you will update p as p is equal to p plus 2 times dx. Again, note down this, that for m less than equal to 1, you have written this expression as p is equal to p plus 2 times dy. But now it turns out to be p is equal to p plus 2 dx, because we have reversed the roles. And for p greater than 0, you need to update p as p is equal to p plus 2 times dx minus dy. Alright, now let us fill this table. In this particular step, so because in the previous step p was greater than 0, so we will update p in the second row as update p is equal to p plus 2 times dx minus dy. So it comes to be p is equal to 5 plus 2 times dx minus dy. Here dx is 10 and dy is 15. So it comes out to be 10 minus 15. So it evaluates to 5 plus 2 times minus 5. And it comes out to be 5 minus 10 minus 5. Now it is less than 0. So in the next step, we have sampled y, but x will remain same. That is, as in the previous row, it will be 101. So again you will be calculating the updating the p. So again p will be updated, but now p will be updated using the expression p is equal to p plus 2 times dx. So it comes out to be, previous value p is minus 5. It comes out to be minus 5 plus 2 times dx. Dx here is 10. So it comes out to be minus 5 plus 20. So it comes out to be 15, and it is greater than 0. So for this particularly for this third row, the p is updated as 15, that is greater than 0. So in the next step you will update, you will increment x as 102. Similarly, to calculate you keep on updating p for every row, and you will find out whether x is to be incremented or it will remain same for the subsequent or the next row. So please complete this numerical. Thank you so much.